Hi, this is Mrs. Murdoch, and today we are going to learn some graphing skills. So I thought I would introduce my puppy dog to you. We adopted a American Foxhound puppy, and on the left here, on this picture right here, you can see she's about 6 months old there. And then over here, this is many months later, when she's a little bit older and more erudite looking. So what I wanted to do was I wanted to show you what the difference is between creating a graph on a piece of graph paper where you have to manually use a pencil and rulers and colors versus actually using Google Sheets, which is a spreadsheet that can build the graph for you. But I wanted to show you with the exact same data set how you can build a graph either manually or using the computer. So here we have a data set that shows age in months of my puppy, going from 2 months, 3 months, and then going up to 14 months, and her mass in kilograms as those months went on and when she was weighed and how much she weighed. So here is kind of a graph grid down here, and the first thing that we're going to do is we're going to give it a title. So when you give a title to any graph in a biology class, you're going to start with the words the effect of, and then in this blank you're going to whatever the IV is. So in this case, the IV is going to be her age in months. Almost always your IV is going to be the leftmost column in a data table, or it's going to be whatever the scientist is manipulating to affect the DV. In this case, we're just looking at time, something happening over time. There's no other manipulated variable here. So we're going to put the effect of time on the DV, which is the mass of the puppy, right? The mass in kilograms of the puppy. Okay, so I'm going to go up here and just make this very clear. Her age in months is the IV, and her mass at the start of each month is the dependent variable, or the DV. This is a very simple observational experiment. We're not giving her any special food or comparing puppies that had different foods or anything like that. We're just looking at something changing over time. Usually when you have an experiment in biology, there's going to be a slightly more complex IV than this. But this is a really simple one, and I just want to show you how to do this graph. So there we go. We have a nice title. Now we're going to go and put the IV and the DV on the X and Y axis. So the IV in time, it's already actually done for me down here. Time in months is my IV, and that goes down here. And then her mass, her changing mass in kilograms, always remember to put the units in, is going to go over here on the side. So the horizontal, or the X-axis, how you're going to label it is going to depend on what shows up in your table. So let's go back up here and look at what that table says. So we're starting at 2 months and going to 14 months. And since this is something changing over time, what do you think? Do you think we need a line graph here or a bar graph here? Something changing over time. If you said line graph, you are correct. It's much better to use a line graph when something is changing over time. You use bar graphs when you're talking about comparing different things. Like if we had 3 different puppies on different foods, then we might want a bar graph. But here, we're going to just go with the time here. So we're going to start with 0 months, and we're just going to go 1 block at a time. Very simple. And go up by ones. Remember that your scale needs to be even. And I'm going to go all the way up, not skipping any months, to keep my scale even intervaled, and go all the way to 14, because I know that is that's the end point of my data collection, is at 14 months. Okay, and I didn't skip any months, even though the data table does skip months. You don't want your X scale to skip any months. Okay, so, and if we go to the table and look at the mass in kilograms, what you want to do there is notice that we're starting with 5 kilograms and we get as heavy as 30 kilograms. So that's going to mean that your scale here on the vertical axis you're still going to begin at 0, but it needs to go as high as 30, and you want to use as much of the scale as possible. So we're going to go by 2s. 2, 4, 6, 8, and here's 10. And then 12, 14, 16, 18, and here's 20. And here's 22, 24, 26, 28, and here's 30. There. Nice even scale, neatly numbered. And now we're ready to plot our points. So each point on the graph, as you know, has an X and a Y coordinate. The first point is going to be at 2 months, she was 5 kilograms. So at 2 months here, she was 5 kilograms, which is right about here. At 3 months, she was 8 kilograms. So here on 3 months, she is 8 kilograms. At 4 months, she was 13. So 4 and up to 13 is right about here. Good. Just going to keep going. At 5 months, she was 19. So at 5 months, up to 19, right there below the 20, right? Oops. Okay. 6 months, she's up to 25. So here's 6 up to 25. Whoop. Okay. At 8 months, she's at 28. Okay, now skip over to the 8, and she's up to 28, which is right here. See how I skipped a couple lines there because there wasn't any measurement taken for month 7. And then we skipped to 14, and she's 30. So we skip all the way over to 14 months. That's way over here, and she's 30 kilograms, which is right here. Okay, now I don't have a ruler, but I am going to connect the dots that are, I'm sorry about that. Difficult to get this to work. This is why. You would be using a ruler and you would have a vertical surface. I'm afraid I don't have that, so I'm doing the best I can here. There, now see, look at how that data kind of flattens out. Now you'll notice that I didn't make a connection in the first 2 months here, like I didn't put anything here, because we're going to assume that since no data was taken, that she wasn't weighed at 1 month old and she wasn't weighed at birth, so we don't really know where she was starting over here. So if you don't have the data, don't put it there. Okay, so that's a good graph. Now let's go over and look at what this would look like on Google Sheets. If I can find it. Right here. Okay, here it is. Okay, so we have the exact same data table. So let me put this so that you can see it better. There. Okay. Okay, there we go. So watch how quickly this can be done. It's the exact same data table, right? But look at this. What you're going to do is you're going to select the titles of the top of the data. Don't select the table name, just the age and months and the mass at the start and all the numbers. Okay? Once you've done that, you press Insert and you go down to Chart. Boom. Done. That's it. It's done for you. All that manual stuff, all the decision making that you had to do is now done for you. What it doesn't do, though, what you have to still add to it is you have to give it a valid title. So mass at start of the month is not a valid title. You can't use that. You have to give it the title that we know is the right thing to do. We go effect of time on the mass of a puppy. And now you have your title. It's already placed in the labels for your y-axis, mass at start of the month, kilograms, and your x-axis, age in months. So you see how nice and easy this is. It's still going to be important for you to be able to do it the manual way. But since we are virtual this year, I want you to have a way to make a graph like this. If you're given a data table, to be able to highlight it, to insert, and then select a chart, and it will give you a line graph. Now, what if you don't want it to be a line graph? You can also change the type of graph. You can change the type of the graph. Chart style. There. Can't find it right now, but you can go and you could do a bar graph instead there. This is line chart, and you can change it to a bar graph. So you could do this, but you wouldn't want to make it like that because if you have something changing over time, you do want it to be a line graph. So I don't want that. I want it to go to a line graph, but you can toggle it back and forth and it will do it for you again. So that is how you build a graph given a data table. And you can do it manually on a piece of graph paper, or you can use Google Sheets, which is where I am here, to have the computer do it for you. And I hope that's helpful.